Invisible vibrations, whether used to manufacture toys or to hermetically seal packaging such as gummy candy burger, ultrasonic technology has long been part of our everyday lives, often without us even realizing it. It cuts food cleanly, bonds functional fabrics without a needle or thread, and joins car parts. Wherever precision matters, ultrasonic technology is at work. It doesn't glue or burn, it bonds using pure energy, efficiently, permanently, and within milliseconds. What sounds like science fiction has long been everyday reality at SONOTRONIC, made in Germany.
The advantage of ultrasonic welding is that we consume less energy than conventional thermal welding methods, since energy is only required during the actual welding process. In standby mode, our energy consumption is extremely low. We don't have to keep tools heated continuously. Welding times are typically much shorter for fabric and similar applications. This makes our operations much more efficient.
Ultrasonic technology is a green technology innovation because it offers an environmentally friendly alternative to conventional methods, such as thermal welding. For example, ultrasonic welding of plastics can save up to 75% energy. At the same time, the technology facilitates recycling. Since no additives are used, components can later be sorted by material type, fully in line with the principles of the circular economy. But how is that possible?
We have a generator, which is an electrical component that is plugged into a standard outlet. It draws power, which is converted into high-frequency voltages and transmitted to a transducer. This is then used to generate mechanical motion, resulting in an ultrasonic tool capable of melting plastic materials. The input amplitude, the motion, is amplified, creating enough energy at the tip of the tool to melt the material. When you touch it, you feel the vibrations when you apply pressure. You feel the heat. This allows us to weld plastics, cut food, and even weld metals. All geometric shapes are designed so that the entire welding surface is used efficiently. This enables us to develop precise welding solutions for our customers. The technology is used less for general applications and more for critical components and sensitive food products, where radiant heat must be minimized. In these cases, the lower heat impact offers a clear advantage.
The idea is simple. Electrical energy is converted into mechanical vibrations. These vibrations set the molecules of a material in motion, thereby enabling materials to bond.
The molecules are set into vibration, causing them to rub against each other. You can think of it like a blacksmith striking a piece of iron with a hammer, in this case 20,000 times per second. This generates heat, and the same principle applies here. The material heats up as the molecules interact. At the interface between the two components, this energy causes the material to soften, melt, and form a solid bond. The individual strands are inserted and held in place, and the sonotrode is positioned on top. The ultrasound is then activated. Through these high-frequency vibrations, around 20,000 per second, combined with constant pressure, energy is introduced into the material. Instead of joining thermoplastics, this process causes the copper strands to vibrate and bond with one another.
In ultrasonic welding, high-frequency vibrations generate frictional heat at the contact surface, allowing materials to undergo plastic deformation. This is how two plastic components are joined into a single unit, and cables are firmly and conductively connected to contacts, without additives, cleanly and efficiently. In ultrasonic embossing, fine structures are permanently imprinted into materials, for example in leather shoes or wallets. The energy is transferred with pinpoint precision from the tool to the material, without the use of chemical additives.
We receive a wide range of sample parts from our customers and evaluate whether ultrasonic technology can be applied. From there, we develop the appropriate solution. What should the tool look like? What is the optimal fixture? How should the welding process be designed? It's all about working closely with the customer to find the best possible solution.
We manufacture the majority of our machines at our own facility. Our high level of vertical integration, especially in ultrasonic technology, allows us to build highly customized machines. That's why it is important for us to communicate this expertise and proudly label our machines made in Germany.
Here in Karlsbad, Sonotronic has been developing and manufacturing innovative and durable ultrasonic components and machines for over 5 decades. From prototyping and ultrasonic tooling to the finished system, everything is produced in-house by experts who truly understand their craft. As a result, every product meets the high-quality standards associated with German engineering worldwide.
Ultimately, every tool is a custom solution. While some designs are similar, each one is tailored to a specific application. In the food industry, cutting applications are common, while in packaging, the focus is on sealing, typically using films to preserve products in the food and cosmetic sectors. At the same time, we continuously receive new and sometimes unexpected application requests, which we first test in our technical lab. Some are familiar, others are entirely new, but even after 25 years, these applications continue to surprise us. We support our customers throughout the entire process, from initial consultation to production and beyond.
We just have the idea to extend your machine with the wallet, with embossing application.
Yeah, I think it's a great idea, yes.
By now, we have established a global presence. Wherever our customers manufacture their products, we are there as well, with local representatives and partners.
With 12 partners in Europe and more than 20 worldwide, the company operates on an international scale, maintains close contact with its customers, and develops custom-built machines tailored to specific requirements.
Ultrasound still holds vast potential for future application. Today, it is already used in processes such as ultrasonic welding, cutting and metal welding, as well as in disintegration applications, for example in sewage sludge treatment and biogas plants. At the same time, there is significant potential for further development. That's why we continuously invest in research and development, exploring new materials and identifying ways to further improve existing customer applications using ultrasonic technology. And wherever we see new opportunities, we actively work to develop those markets.
Whether it's welding, riveting, sealing, embossing or cutting, ultrasound has long been shaping our everyday lives and connecting materials, markets, ideas and people. A true game changer for the future and technology. Made in Germany.